Hello, people. As everybody comes in and joins us for this meetup group, we'll wait for people to join for a little bit and welcome from where everybody is located. I hope everybody is having a wonderful day today. And we are here from as we go through this, we're representing all over basically the hemisphere over here. So I'd like to welcome everybody to our first meetup as we here at NTConsult have recently taken over the meetup group for the West Coast. It was formerly, I believe, a California meetup group out of San Francisco. So we've changed it to the whole West Coast, but really it can be anywhere and anybody. So welcome. We're very happy to have you here with us. And I will, introduce you to ourselves and everybody who we're going to be presenting. And we have a great topic today. So at NTConsult, we've been around this will be 20 years this next year. We are a global software development company. We work out of 8 different countries. Over just the last 2 years alone, we've seen a 74% increase in growth. And I think the remote work team concept has really helped us as we have people working on projects everywhere. So our headquarters are located in San Diego. So we are in California, but our software development centers we have headquartered out of Brazil, and then we have offices in Peru, Uruguay, and Mexico. And why we are taking over this group as a custom software development shop, we live and breathe in the business process automation space, supporting our clients on their journey in this sector for over 15 years. We've been working in the business process automation space. And during a meeting we had with Camunda last year, we heard that the California Meetup group was losing its leadership. So we figured with our San Diego headquarters, coupled with we recently won the Camunda Partner of the Year, which you can see on the screen in front of you. We thought we'd be in a great position to lead this group and kind of take it forward. Our goal is to create an environment that fosters communication between our experts and Camunda users. We hope to be able to put together a schedule of events that touches on all the Camunda hot topics. We are open to any and all suggestions of what you'd like to see covered. With the help of Camunda and our experts, we can pretty much cover on almost any topic. So please send your ideas over. And you can ask questions or send ideas by using the LinkedIn chat to ask the questions. And what we'll do is, as we go through the presentation, if your question is related to what we're discussing, we will have the guys discuss it then. If not, we'll bring it up at the end where we'll have a question and answer subject. And as we've also mentioned, that everybody attending is going to get one free training session from our training division. We'll also have a link at the end that you can sign up for that. So without further ado, I'd like to introduce you to who I have on with me today, myself. I run sales here at NTConsult. I am out of San Diego. And I'll turn it over to Emilio so he can introduce himself.
Hey guys, I'm Emilio. I'm a business process architect. I've been working with Camunda for the past 6 years, and I'm working with consulting on NT for the past 4 years for the North American market. And I'm also now working in sales with Mindy. So if you have any questions, you can come to me as well to understand how we can help you. And I'll pass over to Raimundo.
Hello, everyone. My name is Raimundo Júnior. I'm from Brazil, and I work at NTConsult as a Camunda architect, and together Emilio and other folks, I've been working on Camunda projects on Brazil, Canada, United States, and I'm here to support you and to help you in anything you want. And if anything you need, you can count on me. I'll pass to Josh.
Hi, my name is Josh Wolf. I'm a developer advocate at Camunda. And to give you a bit of a background, I don't know if it's possible to bring in the screen share that I have going. Yeah, so this is kind of a cartoon picture of me I had done by an Indonesian artist. I live in New Zealand, which is in the future, at the bottom of the earth. And I live in a small rural town on the side of the western side of the North Island here. I'm the host of the Camunda Nation podcast, which is a monthly podcast talking about all things to do with Camunda. This month, just to pitch this month's episode, we're going to cover a lot of the great content that we're covering today, top 8 questions about Camunda 8. So if this is interesting to you, you might want to check out the podcast as well. To give you an idea of how I got involved in Camunda, I'm the maintainer of the ZB Node.js client. So I was working at a fintech company in Brisbane, Australia in 2018, and we evaluated Camunda, particularly ZB, against Netflix Conductor, and ZB won that showdown. So we started developing on it, and there was no JavaScript client for ZB at the time. So I wrote one. The company open sourced it. The rest is history. I ended up working at Camunda, and I still maintain that client. And I've been working at Camunda since 2019, specifically on ZB. And kind of a random fact about me, I'm also the 2021 Natural Bodybuilding Classic Physique Champion of the North Island in New Zealand. So I want to kind of kick things off here, telling you a little bit about Camunda Platform 8 and particularly the workflow engine inside it, which is the ZB workflow engine, and give you a sense of the kind of innovation that's been done there. At Camunda, we started working on this 5 years ago at least, maybe coming up to 7 years now. And what happened was that we had the Camunda 7 engine, and we started thinking about what does it look like if we were to radically reinvent the process engine. So we went from the existing Camunda engine, which we still have, we still maintain, we'll be maintaining that into the future. You can still build on that. And we built this new engine, ZB. And to give you an idea of how they're different, let's just look at the Camunda 7 engine. So, the workflow engine, you give it some BPMN, business process model and notation, and then the workflow engine connects to a relational database, and that's used to move things through the process. So the current state of the process is stored in this relational database. It's a pretty standard BPMN architecture. You have database rows in there, which tells you about where that process is at, what's happening in it. And as it moves through the different stages, we mutate the database row. So you got like a database, you got mutation. And then, we get to the end of the process, and that database row is the current state of it. So when we looked at it, really the main thing that we wanted to solve with this process engine is scalability, because the relational database is really a bottleneck in any system. It's not cloud scale, and resiliency of that component is expensive. And when I say that it's not cloud scale, I mean that scaling databases is hard. You can vertically scale them by adding more resources to that single database, but you still have that single point of contention, which is the database row itself. So there's a limit to where you can really take that. And then the other thing is databases don't lend themselves to this new kind of world of ephemeral containers and rescheduling of Kubernetes for efficient resource usage, because they are inherently stateful objects. So they're not a good match for Kubernetes. So we asked the question, what would it look like for us to make something that was cloud scale, and works with Kubernetes. And if you know anything about web scale databases, you're probably thinking MongoDB is the obvious answer to this. And we did actually attempt to use NoSQL database with Apache Cassandra in some of our earliest attempts to solve this problem. But ultimately, we went even deeper than that and just reinvented the whole thing from the ground up. So what we did is we reimagined the processing of this BPMN rather than as like a mutation of state in a database. We reimagined it as stream processing over an append-only event log. So if you know anything about event sourcing, it's very similar to that. We have this event stream, event log, and we append commands and statements about what has happened into it. It's like a transaction log for your bank account or something like that. And from that, we can compute the current state of the universe, in this case, the BPMN diagram. So this gives you a little bit of an idea of what that looks like. In this append-only log here, we see we create a workflow instance. So we send in the command, create the workflow instance, and then the stream processor reads it and then appends workflow instance created. The first one's the start event. So start event occurred. Sequence flow is taken to flow out of that start event. And then we activate that first task here. And then we create a task. And that takes us to a wait state in the engine. So, you know, that's the processing up to that point. Then what will happen is a worker will activate the task by sending a command to the system saying activate jobs of this type, and then we'll activate that job. The job is now locked. No other worker can take it. And again, the system is in a wait state. It's still processing other things, but there's a wait state while the worker is working on the job. There's also an internal timer that will fire when the job times out and allow another worker to take that job. But when the worker has finished the job, it sends a complete job command, which gets appended to the log. The stream processor then processes that and then moves it to the next task in the flow. So event handling, replication, and single writer. So to get the scalability, we wanted to do two things. We wanted to create these clustered workflow engines that can do two things. They can division the work out between them, and they can also replicate the work that's been done so that if any one of the nodes falls over, any one of the other nodes in the partition replication can take over that work. And so we have a single thread that is responsible for writing to the log on each of the brokers. And one of the brokers becomes the leader of the partition. And the other brokers in the cluster are just kind of like replicating what happens. So as an example here, we get the complete task command from the worker. We add the command to the event log. And then what we do is we send that to the other nodes in the cluster. So they are replicating the event stream for the partition, but they're not acting on it. Only one of the nodes is acting on it and appending events to it, but it's replicating that event stream to the other nodes in the cluster. So if the leader falls over, when that's detected by the followers, one of the followers in an election will become the leader and just pick up the work from where it got stopped on the last leader. And so the stream processor on the leader is the one that's doing the actual work. And the kind of internal computed state of the universe from the reduction of that event stream is being stored inside RocksDB in the broker. And RocksDB is like a key value store. And periodically, we'll take a snapshot of the current state of the universe and replicate that snapshot to the followers so that they don't have to recompute the entire state of the universe from the beginning of the event stream. They just compute it from the last snapshot that got replicated. So we're storing and replicating the events and the commands. And we have so that gives you replication and failure tolerance. So if one of the nodes hardware goes away, whatever happens, it can pick up the work. So the other kind of orthogonal concern with clustering, you've got like high performance, resiliency and failure tolerance. And then you also have high performance. So you want to be able to add more and more resources to the cluster by adding more nodes to it. And you want to see like a scalability of your throughput. Like as we add more nodes, we can process more work. That was the main thing that we wanted to unlock, was as you add more nodes, you just get this infinite linear scalability of the system. And the way that we do that is we partition, or shard, if you like. It's kind of like sharding. It's partitioning of the cluster. And so if we have 4 partitions on the cluster, those 4 partitions are spread across the cluster nodes. And one of the brokers in the cluster is the leader, and there are a number of others that are following for resilience. But one of those nodes is the writer into the stream. And each of those, when you create a new workflow instance, it gets created on a particular partition. And so the interesting thing about that is that the workflow key that comes back, the process ID, actually identifies the partition of the cluster that it's running on. So every time you send a command into the system to say, complete a task, with this process ID, that maps it into the particular partition in the cluster where it's running. So we use the external task pattern for this. So none of the code, so we're going to touch on this as we go into it, but there's no delegate code running inside the cluster anymore. If you're familiar with the external task pattern in Camunda 7, this is like a completely decoupled job worker pattern where the business logic code lives completely outside the engine, outside the system. So it's like a publish subscribe model where your workers subscribe to a particular type of work, and they're actually polling for that work periodically. So what that means is that you can scale the workers independently of the cluster as well. So you can do things like create workers that, and then in a Kubernetes layer, the pod scheduling, you can, on a metric like CPU usage, network usage, memory, or even your own custom metrics like, how many tasks am I handling and how long are they taking? With your own instrumentation, you could cause more workers to automatically scale up. So you can, depending on the load on the system, you can scale up and down the workers that are working on that. So everything goes through a gateway, which has the brokers behind it. And you can do things like put reverse proxies in front of the gateway. You can even cluster the gateways behind a proxy that has multiple backends. And then those brokers live behind the gateway. All of your workers, all of your applications that are sending commands like starting process instances, they talk to the gateway. For queries and read models, so effectively, the broker system is a write only with kind of one exception, which is this activate jobs call where you're activating work for the publish subscribe for the workers. Otherwise, you can't query the state of the system. So the way that you can get an insight into what's happening is that the event stream is exported as it happens. So as well as like replicating that event stream to the followers in the cluster, we allow you to load exporters into the broker, which can stream that event stream out to anything that you want. You can write your own exporters, and we have one that we've written for Elasticsearch that exports all of the events into Elasticsearch. And with one of the components of Camunda Platform 8, Operate, it creates like a reduced state that allows you to query the current state. It's like the equivalent of Cockpit from Camunda 7. And you can query that over it has its own API, which is a REST API. We're going to touch on the various APIs of the system as we go through. But one thing to bear in mind about this that is a little bit different, and this can sometimes catch people when they come from Camunda 7 to 8, is you're no longer looking at the current state of the universe. Whereas before, if you looked inside a database, you could see the current mutation state. You're looking at like a state reduction of an event stream, which represents something in the historical past that happened. So if the system is under an incredible amount of load, for example, you may see things like a slight lag in the updating of the current state. It's just something to bear in mind about that. So yeah, you can't ask the ZB broker directly. So we've got to go into Elasticsearch, and then we query it out of there. And that is my overview of the Camunda 8 ZB workflow engine, which we're going to touch on the questions now.
Thanks, Josh. That was awesome.
Okay, so to start it off, our first question touches exactly on remote engines and embedded engines. What are the difference? Why this change of paradigm from Camunda 7 to Camunda 8, and what is expected from that, and what is common between Spring Boot implementations? So, Josh?
Yeah. So the advantages of the remote engine over the embedded, really there's kind of a couple of main advantages. One is the scalability piece.
Mm-hmm.
If you want to have a system that can like scale massively, then it really does need to be a remote system so that you can do things like the clustering, that kind of piece. The other advantage of that remote engine over embedded is like the management. We have things like the ability to detect versions, that are running inside your applications. But when you embed the engine inside your application, doing an upgrade of the engine itself requires like a redeployment of the application. So then you're kind of it becomes less of like it kind of conflates the DevOps and the application development concerns together. So separating those two things out means that you can make the engine and the engine management purely a DevOps group concern rather than conflating it with applications. Conway's law says that the structure of the organization and the structure of the system that you produce are going to be they're going to look the same. And the classic example is if you have a team, 3 teams working on a compiler, you're going to end up with a 3-pass compiler. Even in scaling the ZB engineering team, part of the conversation there is how do we divide this up? And the obvious thing here is the BPMN related code and then the distributed system clustering code. And if we separate, into 2 teams that deal with those 2 different pieces of it, now we have to separate the code base so that they can work on those 2 pieces independently. So when you make the engine remote and not embedded in the application, you now have the opportunity to have a team that deals with that. When you're putting it in Kubernetes and you've got like auto scaling, that kind of stuff happening there, then making it a purely DevOps concern is a good match.
It makes sense. It makes total sense.
Okay, Josh, when we are talking about the news about Camunda 8, we face that the remote engines come with some limitations. We don't have delegates, for instance. What strategies are recommended for overcoming them? Like what to do instead of listeners and how to replicate the functionality we had with global listeners and engine plugins and, of course, delegates.
Yeah. Okay, that's a great question, Raimundo.
Yeah.
Yeah, I don't know if I would say that not having delegates is a limitation. It's kind of more like it's a characteristic of the system. It doesn't use delegates. It uses the external task worker pattern. I think one thing when you're looking at it to bear in mind is a question you got to ask yourself is, should I be doing this? Should I be using, are the characteristics of Camunda 8 a good match for the problem that I'm trying to solve? And, we really created Camunda 8 in the ZB workflow engine to solve a particular class of problems in a way that they hadn't been addressed before. But if that's not your problem, maybe it's not the best solution. I just want to frame it like that for people. So you shouldn't feel like you need to go like, we have to go to Camunda 8 because it's the new hotness, it's the next number, so like it must be better. It's like it was developed to address a particular class of problems. And yeah, there are some characteristics of it that it doesn't have listeners, for example. If you do have this class of problems, we need this massive scalability, for example. Okay, now you're going to have to do it. You have some experience with Camunda 7. So you are asking yourself, like, I'm used to having listeners. I'm used to doing things a particular way. How am I going to do it now? So there's kind of a couple of things that you can do. One is going back to that kind of first principles approach to it. Like, what's the actual problem that I want to solve, rather than trying to figure out, and I will tell you how to hack in listeners. But I don't want to start there. Like, that's not the first place I would start with. It's kind of like, we need a scalable database. Let's use MongoDB or Apache. Cassandra, and maybe that's not the best thing. Maybe you need to go back to ask the question of, because to put it another way, listeners was the solution for the problem you have in Camunda 7, but there are no listeners in Camunda 8. So maybe, and probably, the solution to your problem using the primitives that are available in Camunda 8 is a different thing than the listeners. So it's kind of going back to like understanding what are the elements, the simple, strong, powerful primitives in Camunda 8, and how do I assemble those to solve my problem. Now, if you wanted to do something like listeners in Camunda 8, you could do it. Not you can, you could do it using the event stream exporter, which gives you an ability to listen inside the engine, if you like. A couple of things about that is that is like a global listener, because it's listening to everything that's happening in the engine, and you can filter on particular event types that are of interest to you. But then you'll have to write another filtering layer on top of that to do things like subscribe to the particular or correlate with particular process instances. So you're now writing at another level of abstraction. You're no longer inside the engine, and you can no longer rely on the engine, this delegate kind of idea, activating your code for a particular process instance. You're now writing this kind of like abstract listener outside the engine. So you're kind of writing your own engine plugins remotely from the engine. And I can envision someone going nuts on this and writing something like that, some kind of framework that does that kind of thing, and then open sourcing it on, on GitHub, on the Camunda Community Hub. And people have done that kind of thing. You got like Simple Monitor, for example, which is kind of like an open source alternative to the Operate component, which is like Cockpit. And it does exactly that. It listens to the event stream and then creates like an operational interface. And effectively, you're doing the same thing. But I don't know if it is the best way to do it, because, that's an obvious match for an operational concern. It's not necessarily an obvious match for a business logic concern. So you might approach the model differently, is how I would do it in the first instance myself. I would probably write my model differently using the primitives that are available in Camunda 8. I don't know if that kind of makes it clear, or what do you think?
Yeah.
No,
it's clear.
It makes sense. Yeah, because you don't have these two, but you have other tools that you can use, like scripts, or that is more powerful now in Camunda 8, that you can actually add that logic there and explicitly on the model, instead of having implicitly on the listener that is on one of the elements of that model. So that would be a good approach to how to add this logic to whatever process you're doing. And the solution you said, it works as a global listener. And yeah, it is a case that we have a lot. That is, okay, customers such and so needs to expose a milestone on the process to another system of theirs to know where the process is right now, without the need to consult the query the engine every time to know how things are going. And they just want to grab that milestone and throw somewhere else. And that solution works perfect for that. It is exactly what we need there. What I don't see it working is if you need to also throw it back something to the engine or do some calculation to the process itself and throwing it back from the event stream to calling. I suppose you can call the API then and change something, but there is some delay there that might screw things up if you try to do that. So you have to be careful.
Yeah, I guess the other thing about that is that at that point, your model is no longer an authoritative single point of truth about the behavior of the system, because now you've like encoded behaviors that, looking at the model, you're like, how come it just did that? So in a sense, it kind of forces you to be very explicit in the model about the behaviors you want. Even the milestone, I could see a milestone listener, as like a thing, like an exporter, and it's designed and you create milestones, or you could have an interface where you say, when this happens, do this.
Yeah, exactly.
But looping back into the engine again, that is the kind of case where I would probably go back to the model itself. Even with the milestones, you could explicitly put that in the model, like, hey, at this point, send
we usually do. Well, what we usually use is the intermediate event, that is an event that does nothing, and just catch those and use as milestones to whatever we're calling. So that works well.
And Josh, talking about the operate/event stream relationship, let's say, can I have some kind of mechanism to coordinate or to select specific situations like the Camunda global listener that we could program and say, okay, now I have an intermediate event that has to execute some kind of call or some kind of action. Can I have this kind of mechanism between operate and the event stream? Can I configure that?
No, not in operate. No, you couldn't do that in operate. It is the kind of thing that you could do with an event exporter that you load into the broker itself. And this might be a good point in time to mention the difference between Camunda Platform 8 as the SaaS hosted version or the self-managed version. And one of the key differences is that Camunda Platform 8 SaaS, you can't load your own custom exporters in there. It has the exporters that are loaded, the Elasticsearch one, and that's it. Whereas for your self-managed one, you can write your own event stream exporter and load that into the broker. But you wouldn't, in order to keep that DevOps application, business logic separation, you wouldn't want to put the business logic into the exporter itself. That would just be like a real kind of a filter and a transport mechanism to get it to another system where you have something else that catches that or reads from that, like we've done with operate, to perform actions based on things that happen in there. So it would be a real simple kind of like exporting the stuff into something, and then you write another layer that listens on that and does those kind of things. I don't know also about the intermediate catch event. You see that's actually, this is a really good point here, is if you look at it, intermediate catch event, an event that literally does nothing, it's not a very good match for this external task worker pattern, because in order for anything to happen, something has to, it's like IBM, nothing happens until someone makes a sale. It's kind of like nothing happens in this engine until some unit of work is created, because there's no business logic code running inside the engine to catch that event. So you need to send a message, or you need to create a task, one of those kind of things.
You will not register just that it passed through the element. That's what you're saying. It has to have something that the broker will need to act upon. to actually create something in the stream for these elements.
Well, for something to happen somewhere, like even if it was an element that like it literally does nothing except write that, hey, this happened, and then nothing, after that, something has to be listening to the event stream to see that.
Mm-hmm.
I see what you mean. It's kind of like a way of writing something into the event stream that causes nothing in the broker, but it sends a signal to listeners on the event stream.
Yeah.
Yeah. In this case, global listeners acts almost like the external task workers.
Yes.
Grabbing some kind of event and work on that.
Yeah, but scrubbing everything that goes through and not just pulling for something. So that's the difference.
Yeah, it's clear.
Yeah, I'm wondering if the intermediate catch event is actually implemented yet in Camunda 8. I'm going to see if I can find that. It's not a symbol or a pattern I've ever used. Because that's another good point, is that Camunda 8 doesn't have the same level of BPMN symbol support that Camunda 7 does.
Yeah.
It's kind of like it's this thing, this system that just scales up massively, and it does that like really, really well. It introduces complexity about how you tune the system. Like once you get into this distributed system with streams and like back pressure in different parts of the system, it starts to have like almost chaotic behavior. And then it has like a much simpler set of primitives to work with.
But that's now, right? The tendency is for that to change, and you have better coverage of BPMN.
Exactly. Yeah. And so it's always a question of, do I do it? Do I start a new project on it now? Do I, shift this project over to it now? Do I wait until the future? And it's kind of like understanding the horses for courses piece. Like, when is the right time to switch? And I guess the most simple way of putting it is, if you understand Camunda Platform 8 and what it does right now, is this the solution to the problem that I have
right now?
I guess that's where like Camunda partners like NTConsult come into the picture, understanding both Camunda 7 and 8 deeply, and then being able to advise people on those kind of questions.
Yeah, for sure. So going to our third question. So for current Camunda 7 projects that use the embedded engine, we have synchronous transactions and also synchronous calls made through Camunda. So for instance, we have delegates that call APIs directly instead of depending on a pooling mechanism to grab the task like is the external worker and then calling the external API. Is there any way of doing synchronous calls? How the need for synchronicity in Camunda 8 works, or if it works at all? Because as we talked before, maybe then it's not the case of Camunda 8 being the solution right now if you need that, but how does that applies to Camunda 8 right now?
Yeah, it's a great question. The embedded engine and the synchronous calls, how do we implement that in Camunda 8? Okay, so with a caveat, I'm going to say a caveat here, like anything is possible with enough code. But you've always got to ask the question, should I really be doing this, like embedded engine. I've actually embedded the ZB engine into Minecraft, but it's like, should I do that? As like a crazy kind of technical demo thing, you can make anything happen, but are you going to be able to support it in production? What are the long-term consequences of doing it this way? Like, is the community going to move in another direction and then I end up maintaining this fork, separately? These are the kind of like questions that they're not simply technical. And I'm just kind of framing this, before we jump into the how to actually tactically tackle the synchronous ones. It's kind of like when we built the ZB Node client, and the argument that I gave to the company for why we should open source it is I said, right now, there's no Node.js JavaScript client for ZB. We've just written one for our own use. Now, if we keep this internal and we're using it, we build our system on it. In the future, there will be some widely supported approach, community / official client. And if it's not our client, then we're now going to be snookered into the situation where we either have to maintain our own code base on our own forever with no other support from other organizations, no bug reporting, no patches, or we're going to have to rebase onto the common solution later, which is going to be a technical cost. So there's going to be a technical cost for us in the future if we don't make it the widely supported and accepted solution. I mean, I don't want to turn this into a pitch for working with consulting partners, but that is exactly the kind of long-term vision that working with. It's kind of like if you, and this is why we went to Camunda, to get this kind of input, and working with partners, is that it's one thing if you do one implementation, it's another thing if you do 100. And you've seen like so many, and like what are the long-term consequences of doing things. It's like learning from other people's experience is always cheaper than learning from your own. Okay, so to the question of how would you do the synchronous calls, maybe you could give could you give a concrete example that we could look at, and then we could have a look at how would we do this in Camunda 8, or if it could be done at all.
So we have some customers that have a really strict need for response time. For usually banking clients, they need every service that they call to be like 10 seconds tops response, or otherwise they time out the call. And the problem is, if I'm adding a queue and a worker that will consume that queue to then make the call for that API, I'm talking about 2-3 seconds that I lose from the timeout, only to wait for the pooling system to do their job and then make the call. So and since this, usually for banking, this is not a single call. It's a call that implies another call and another call and another call, and they have to happen in a very close time frame. The time frame that you need to obey. Otherwise, everything goes times out and rolls back. So this is the scenario that we usually have. We have 2 or 3 service calls that need to happen one after the other, and Camunda needs to initiate that communication to maximize the timeout that we have for that call.
Okay, so let me see if I've got this. It's like, let's say 3 service calls that take place sequentially, and the worker that services those calls it has a queue. It's like, is it rate limiting against an external API or?
No. The queue I mentioned is for the polling on the external test, so the topic that you have for the external test. So right now we are doing delegates. So when it reaches the element, we call the API directly, and I have 10 seconds to timeout. If I need to then throw into a topic, wait for a worker to consume that topic, and then make the call, I lost a bunch of time in that polling of the external worker itself. Mm-hmm. And that's what I need to avoid. And I don't know how to. One of the possibilities that were mentioned to us was, do the worker do the 3 calls themselves and then come back to you. And then the worker can do it synchronously. And you have just the polling for the first one. But then we go back to hiding logic. I'm hiding logic in the workers then. I have 3 calls that are being done away from the process, and I have no clue of what's happening. And that's what I would like to avoid. I'd like to have everything as clear as possible in the model.
Yeah, I totally get that. Okay, so this is a statement about the time lapse between the work being available in the broker. Like, we've reached this stage here. How fast can this thing be serviced by a worker? Like, how much latency does this introduce into the system?
Mm-hmm. Exactly.
There's no way of doing a synchronous call. it's all decoupled external task worker pattern.
Mm-hmm.
So
Yeah.
the straightforward answer to that is no, there is no way to do that.
Mm-hmm.
The next kind of follow-on obvious thing about that is like, well, then how do I make the system work as fast as possible, and how fast can it work? And the answer to that is that you can have the system working like as almost as if it were synchronous, at that kind of speed. But because it's a distributed system, this is where it starts to get the complexity starts to come in. It turns out that the obvious intuitive thing you think is if I add more workers, it should make it go faster because there's more workers available to service the tasks. But the more workers that you add to the system can actually cause it to go slower.
Mm-hmm.
Because every time a worker polls the system for some work, it's another event on the event stream. It's more processing for the broker. And if the broker is under significant load, then, everybody asking, it's like, you're driving and the kids are in the car and they're always like, are we there yet? Are we there yet? Are we there yet? How far is it? How far is it? I mean, that doesn't actually slow your driving down at all, but it's the same kind of thing. The more workers you add, the more they're asking for work. And then this is getting really kind of into the technical details of it. The amount of work that each worker asks for, you might think that if I have a worker that says I'm capable of servicing 5 jobs in parallel because it has 5 worker threads, might be faster than a worker that has a single thread, but that can actually slow the system down as well. So in some cases, we've seen people setting up a system and they get this resource exhausted back pressure message from the broker when they have workers configured to accept 5 jobs at a time. And when they dial it down to 1 job at a time, it actually, the throughput, increases. And that's counterintuitive for people. They're like, well, this doesn't make any sense. It should be like, more is more. More capacity in the workers means more throughput. But then it becomes a case of like 5, ask a worker with a capacity of 5 might be good if you had, and the question that the user asked was like, this is with 20 process instances. Why is it like getting back pressure on 20 process instances like this? Like it's a complex distributed system. You might actually find that it goes faster with that configuration with 20 process instances a second or with 20,000 process instances. So the thing about this decoupled external task worker pattern and the distributed system and the streaming and the back pressure and everything is that this becomes like a chaotic system with like multiple variables. And one of our internal consultants, Falco, built this ZB performance tuning tool. It's a spreadsheet. It's got like about 100 columns in it of all the different parameters that you can possibly tune. And then he runs experiments on different systems for customers and, finds out the kind of the performance envelope of the system and how to optimally tune it for different cases. That's the kind of thing that shows up when you're consulting and you're working across hundreds of customers.
Yeah, it's the difficulty of finding the right balance for the amount of work that it's available and the workers that will work on that, because it doesn't matter if I make the worker take like 10 activities every time and then 5 of them are timing out because the worker doesn't come to them, don't respond to them on time, then I'm just adding back to what the other workers need to do, and the other works may be starving because someone else hogged all the activities, and there you go. That's a whole other discussion of how far this can go and how important it is to actually do that separation between DevOps and development, because this is some adjustments that DevOps can focus on, and developers can focus on the process themselves.
Exactly.
And just mention, I think Camunda 8 came to solve this kind of problem, right? We have the workers, we have this kind of external task pattern working better than Camunda 7, right? And we have more scalability, we have more availability, and maybe we don't need this kind of synchronous calls inside the Camunda 8 architecture right now. Can we think like that?
Yeah, exactly. Not only do we not need it, we don't have it, and we're not going to get it. So we kind of have to think like that, right?
Yeah.
It's like, yeah. And in solving one class of problems, we've introduced a new class of problems now, which is how do you tune these things for this? If you have it, as you say, Raimundo, in the engine, being synchronously called by the engine, the BPMN processing and the API calls to the external system are now competing for the same resources. And so, we move them out so we can scale the broker up. But now we have to tune the pressure through the system. And after doing all the experiments with Falco, and I got into doing all that kind of stuff as well, I think that I don't know if we were like, could we get an AI to solve this problem? And it might be possible to program an AI to solve it, but humans are kind of amazing with like intuition. And I'm sure that after like tuning like 5, 10, 15 of these systems, that you guys are going to develop like a kind of a sixth sense. It's kind of like a black art of performance tuning.
Yeah, understand. All right. Okay, we have the question 4. For Camunda 8 SaaS, web modeler is used to deploy processes, but for self-hosted, what is the best strategy for DevOps and project management? And are there plans to have web modeler for the self-hosted implementation of Camunda 8?
Okay, great question. I'm a developer advocate. I'm not a consultant, but I can play a consultant on the internet. So I'm going to say it depends.
Yeah, that's right.
And then, of course, the next question is, what does it depend on? Like, what is the best strategy for DevOps and project management? And you mentioned the web modeler, which is part of Camunda Platform 8 SaaS. So you have this, it's Kawimo, but it's got like the beginning of the technical implementation, connecting your process model to the technical implementation. And then deploying from the web modeler directly into a running cluster. So cool. It also has like Google Docs, like collaboration features and like milestones. So you can roll processes back through their history. It's really cool. And it makes for like a really amazing rapid application development experience. You can collaborate, technical and business users can collaborate in the same space, and you can go directly into production, or not production, but yeah, you could if you wanted to. But is that the best thing to do? But you can go directly to development, to staging, to testing from there. And very rapidly, so you can iterate on the model, run instances of it, and then get the immediate feedback and do that. So that REPL kind of the execution, processing, and then looping process is great with that web modeler. Is it the best way to do DevOps and production deployment? Probably not.
Depends.
It depends. Yeah. I mean, maybe you want to have all of your assets in the same revision control system and tagged, so that your code and your models are tagged with the same tag, and it's all in one place, like in a source control repository. In which case, you might use the web modeler and the integrated experience for that collaboration, for that rapid application development. And when you're at certain points of it, you'd like drop it into, export it out, and put it into a revision control system. That's how I personally do it. I use it that way for like just very quickly getting to some point of like, we're going to push this out to a testing or stage, export it into a source control system, tag it, and then have it even automatically deploy into a cluster from there. So you can do that kind of stuff where you can tag something in source control and have it deployed into a cluster. So I would kind of do it that way. Is it the best strategy? Again, it depends, right? And those are some of the considerations around that.
Yeah.
You have any thoughts on that? Like how how are the kids doing it these days out there in the world?
No, usually for Camunda 7, you end up having uh, some source control because you have the dependency of a Java project as well, which with 8 for the process you don't need to, right? You don't have a Java process associated with it. So that is the difference that uh, I was wondering is that okay? So if I don't even need a process here and I can deploy directly from the modeler to production or whatever I need, uh, should I have actually um, another infrastructure for deployment as well, or should I just go on and deploy it directly from the modeler? But yeah, uh, it is a good practice to, as you mentioned, have tags identifying the versions and all the jazz, so you know what you are deploying at every single time on your system. It might take a little more for automated deployment, but shouldn't be a problem.
Yeah, I think the DevOps infrastructure is something unique on the company's structure, and for this DevOps infrastructure, for instance, we have a lot of customers that do the DevOps in a way, and the other customer do the DevOps in another way, and because of that, it depends. It depends of the DevOps infrastructure, and of course the web modeler can be implemented as well as a front end application, but of course we can use the web modeler on Camunda 8 SaaS, and the Coimo is a very good option as well for Camunda 7 users. And yeah, we have a lot of options, and I just want to say that we have to separate a little bit. If you can agree, Josh, we have to separate a little bit the DevOps part and the web modeler part, because it's different approach, right?
It is, yeah. I mean, there's kind of
Yeah.
two aspects to that, and this speaks to the second part of this question. Are there plans to have web modeler for self-hosted? Yes, there definitely are. It's very highly asked for, as you can probably imagine. Everybody's like, can I get that at my place? There are plans to do it. Like, when is that happening? Soon. What does soon mean? Not tomorrow, but it's high on the priorities of like, what are the things that are coming? Of all the things that we could do, this is the one that people really are asking for. And then this just foreshadows a question we have coming up later on, but deploying the web modeler becomes a DevOps concern, as well as, how do you deal with the assets that are produced by the web modeler?
For sure. Yeah.
Okay.
So if we have a 10 minutes break now. If you guys have any questions, please ask them in the appropriate channels that we provide, and we'll see you in a little bit.
Yeah, and we'll have, after the break, we'll also have some questions and answers if the questions, once again, are not pertinent, have nothing to do with the topic we're discussing. So please send over any questions around Camunda 7 or 8. So take a break, grab some water, and we'll see you back in 10 minutes.
And a cup of coffee.
And we're
Welcome.
back.
Yeah, we're going to go right into. We thank you for your questions that you posted, and we will be covering those at the end. And we will go right back into question number 5.
So number 5 is something that we are asked a lot. So how to implement customized or even an external task list with Camunda 8.
Yeah. Okay. Best alternative for someone who wants to implement their own task list. It's kind of 2 ways you can do it. We have a question about the different APIs, right?
Yeah, I think it's the next one.
It's the next one. Okay. So I think maybe we could go to that question first, because I think really to really answer this one, it's going to be an overlap, because there are different APIs that you can use to do this. So maybe we can jump to question number 6.
Let's hope it's 6. Yeah, it is. Yes.
Yes.
So, so this question is about the different APIs, the API technologies that we have with Camunda 8. You have gRPC, you have GraphQL, and you still have REST there. But each one of them is responsible for a part of what the system can do. So, what is the thinking behind this of having the 3 different APIs? So what is the difference in scope between them, and how can we go on into combining them? Like, and this is an example that we gave here is the task list. So I have to search GraphQL for the task list, but then complete them in gRPC. So how can I go about and do that simpler and not having to string along a bunch of API calls if we can do that in a simple call?
Yeah. Okay. Okay. So the different APIs, and this kind of like, it's useful to understand the history of it. So with the ZB broker, we went with gRPC. It's a highly efficient binary protocol. It's compressed, and it basically is this kind of gRPC, you know, like a remote procedure call, came out of Google. Apparently, something like 60% of data flowing inside data centers is gRPC. Most of the communication over the kind of open internet is REST, but inside data centers, it's particularly useful for that. So between the gateway and the brokers, they speak gRPC. The gateway is sending, you know, calling remote procedures at this API calls. And, you know, we went with that for the communication between the application clients and the gateway and the broker. So our idea there was that you deploy your applications inside the same cluster in a data center somewhere, and all the communication over gRPC. So then the next interface that came about was there are kind of 2 REST interfaces. One is for querying operate. And one of the interesting things about that is, you know, I said at the beginning that ZB is kind of like a write-only system. So there's actually no way for you to query the system to find out what process definitions are deployed in the system. There used to be a remote procedure call for that right in the beginning, but they were like, we want to make it write-only, so no read queries. And as a result of that, to find out what process definitions are deployed in the system, you can either just try to start an instance of one, it'll throw and tell you that it's not found, or we added a call to operate that allows you to ask operate, and operate maintains the historical record of all the processes that were definitions that were deployed, and so you can get them back from there out of Elasticsearch. And then you have another REST interface, which is for Cloud Console. So that's for doing things like even provisioning new clusters can be done. and that's done over REST. So you're talking to like the management backplane for the Kubernetes infrastructure. And then the final one is the GraphQL interface. The GraphQL interface is used for querying task list. So finding out about the user tasks that exist. And task list is a component that we've written that gives you like a basic interface. You can define forms, you can deploy those, your task list component runs, and then when a user task is created, a user task is simply another service task that just gets serviced by some other worker. So task list is an external worker that activates jobs over gRPC, and then it puts them into its own interface there, and you can claim those tasks, you can complete them, you can fill out the form in the web interface, and it also exposes a GraphQL API. And there we went with a GraphQL API because it's a good match for building your own front-end JavaScript applications that are asking for complex sets of data and want to query on various parameters. Instead of like pulling down all of the data and then filtering through it, you can very easily express server-side queries in the GraphQL query so that the server fulfills the query for you and gives you back the exact data shape and structure for the exact things that you're looking for. So that's kind of how we ended up with these three different interface or API kind of types.
Yeah, it's clear.
Okay.
It's clear. And
Now,
okay, go ahead. Go ahead.
No, I was going to ask. Okay, then going back to question 5.
Yeah,
If
I
I'm
would say
doing a task
Yeah.
list, how should I proceed then?
Yeah, so this is a great question.
You mentioned that. Okay, so the task list is just another worker, a different worker that grabs the task. But if I need, can I, for instance, have a custom worker doing that instead of the default worker for a task list, and then I'll have that being processed anywhere else? And the reason I ask this is because if the solution is, send it to an external worker to throw to your custom interface or something like that, but in the model I'll have external task instead of user task, then I don't want it. I want it to be explicit that this is a user task. See what I mean?
Exactly. Yeah. So actually, I haven't checked this recently. Let me just check it now. A new BPMN diagram. The user task when you create one. So I'm just going to drop a user task into my model. I'm just doing this in the background to look at it. And then so everything is a service task.
Mm-hmm.
And okay, can I give it a specific type? General name? No. Okay, in the modeler, yeah, it doesn't look like I can change the type of the user task. So I think the type is something like, in the background is something like Camunda human task. You could actually go in and edit it in the actual XML itself to change that.
Mm-hmm.
So you could create your own. Yeah, you could create your models with a user task in there, and then just change the task type.
I see what you mean.
And then have your own custom worker picking them up. In which case you would have actually no in the yeah, okay, it's actually defined as a user task now in the model. Okay, so yeah. Could you then create your own external worker to pick them up? If you didn't deploy the user task component, then yeah, you could deploy your own workers to pick them up. And then you would be responsible for everything. And why would you want to do that rather than using the GraphQL interface, which gives you basically things like assignment, identities, groups, all the kind of stuff that do I really want to implement
all the life
that stuff
cycle
myself?
of of a user task, right?
Unfortunately, not all the life cycle. Task listeners.
Okay.
So you can't trigger you can't trigger a lifecycle event on this task was claimed, because that's now taking place in an external system. So there's no, it's not on the event stream of the broker. It's all happening. It's like, you know, the unit of work has been claimed by an external worker, which in this case is the task list system. But we know that human tasks have their own life cycle outside of the broker, now outside the broker, right? Of like, was this one assigned? You know, has it been reassigned? What's happening with this thing? Listeners on those kind of events are at this point in time not available. If I was like, I really must use Camunda 8 and I really must have human tasks and I really must have like lifecycle management of those tasks, then yeah, in that case, and I think that's a real edge case, because the investment required to do that is you're going to build your own parallel fork of the Camunda task list component with lifecycle, you know, hooks in it. And it's likely that lifecycle hooks will come in the future for task list. So if you really needed that piece of functionality there, I wouldn't implement it. I would use Camunda 7.
Okay. Perfect.
Yeah. What are the best alternatives for someone who wants to implement their own task list? Depending on how much and why you want to do it, I'd probably use the GraphQL interface personally, because if there's things that you needed that require you to like go down to the depths and throw away everything that the task list component already implements, you're probably better off going to Camunda 7.
Agree.
Now.
Okay, thank you. Raimundo?
Okay. Question 7. Implementing a cloud-native application requires new roles and new capabilities within our teams. Can you describe the internal stack and what skills we need to be leveraging, not only to implement the projects, both SaaS and self-hosted, but also to operate Camunda once in production?
Yeah, okay. Between the two, SaaS and self-managed, quite a lot of difference. You know, it's now all cloud native, so it's all Kubernetes, Helm charts. If your organization has like a Kubernetes infrastructure and teams working on that, then, you know, you have the people who are going to do it. If you don't have that, then SaaS is a great option, because, you know, maybe you don't have that kind of team in-house, because you don't have that kind of scale of like operation. But guess what? Camunda does, you know, it's kind of like, you go to a consultant because they're going to do 100 implementations, and then you use SaaS because they have 100 deployments. Whereas you like have one implementation, one deployment. But it's like, I want to tap in and leverage the skill and the scale of like, you know, these organizations that have that. In terms of the stack, there's a, I'm going to blaze through these last two questions because I want us to get to some of these questions we've been getting from people, and they touch on this. You know, it's all Dockerized now. You know, you can run it in Docker locally, and then when it gets deployed into Kubernetes, you know, it uses the Docker containers there. So in the internal stack, you know, there's the various components of it. There's Keycloak, you got Operate, which replaced Cockpit. You've got Optimize, which is the same as Camunda 7. Identity, you've got Task List, which we talked about. You have the Cloud Console and the Web Modeler. And so Cloud Console and Web Modeler are two components that's for like provisioning new clusters, and then, you know, making the models and deploying them into the cluster. Those two are not in self-managed yet, but they will be coming in the near future. So that kind of gives you an idea of the internal stack. And then skills to leverage to implement the projects, the same skill set that you have now, but now there's this separation of DevOps, much stronger kind of DevOps story around it.
Okay.
Perfect. Thank you. Then question 8 is about DMNs. So what are the differences we can expect right now? Or what are the limitations and how we should get around them? And what are the new capabilities and how you guys expect they will be used for? And for what use cases?
This one is this is like a kind of a part of the system now that's like right at the very kind of edge. Like we only recently in the latest sort of release brought DMN into the actual engine, if you like. It's not in the engine; it's an external worker, as everything is. But we have the Scala DMN worker that has been used. It's available in the SaaS. You can use the ZB DMN worker for self-managed, and we have it deployed in the SaaS version. And it uses the Scala DMN engine. You can even actually use the same engine with Camunda 7. And it uses the Scala feel, or the feel Scala engine in the background. So it uses the friendly enough expression language. So you can evaluate expressions using feel in there. That's pretty much all that I have about that at the moment. If you have a look into the GitHub or the DMN worker, you can see there's an epic in there to bring it in as like an official project, and the kind of steps that it's going to go through to do that. I haven't done a whole lot with DMN myself. We ran the code studio at Camunda Summit, and basically, just even the ability to deploy DMN tables into the cluster itself is like I just recently implemented it in the ZB Node client. So I don't know, maybe you guys know some more of about limitations, especially with respect to Camunda 7, which I also don't have a whole lot of experience with, especially compared to you. What's your take on it?
We saw that the coverage is similar, but different elements of the DMN. So there are some changes between one and the other, but not very significant. So it is pretty much covered. DMN right now, the biggest one that we saw that is not yet is DRDs. So the linked tables are not there yet, but I believe that should be right to the next releases. So not too worry about that, because you can go over without them. It just is a little more work on top of that, but it can be done.
And in my opinion, having Phil on that is a great news, because people used to implement DMNs using Phil expressions, and that's a great news about Camunda 8.
Yeah. Apparently, some people say that that with the DRDs. Anyway, I'll just be really speculating about it. But that point that you made about the DRDs is that's the thing I heard about it as well, as the one point where it's not at the parity yet.
Yeah, but DMNs existed before DRDs were there, so there is ways to do it. So it's just a little more work, but yeah, elbow grease, no problem.
So why don't we move to questions that we received? We have 3 minutes left, so we're going to go through this really quickly, and after that, we'll quickly pop up a link to be able to register for the free training session we are offering as well. So go ahead quickly.
Rapid fire. What's the criteria for partitioning? It depends. You could do 20 partitions with no replication if you wanted like massive amounts of throughput and you didn't care about resiliency. Like, these are ephemeral processes. We can afford to lose them if a node goes down. Or, depending on the amount of resources that you have available and the failure tolerance that you want versus high performance, that's how you'd calculate that. See a consultant for more details. Is the provided Docker container the recommended deployment option for production? No. Kubernetes is the recommended deployment option for production, either self-managed or in the Camunda SaaS, where we manage it for you. The provided Docker container is a good option for local development on your machine.
So,
Are those the only? That's it on the final questions. Okay, everything else was covered during the presentation. So at this stage, then thank everybody for joining us. If you want to pop up, we can share the link to be able to register. If we have that available?
yeah,
that-
it is on the comments right now.
Yeah.
Okay,
From
so
the
that's
comments.
That's already sent, so everybody has that. And please stay tuned for our next session. If you have ideas of subjects you would like covered, we would love to hear from you. We're open to any suggestions, so we appreciate your time, and we look forward to seeing everybody soon.
And let us know how it went, if it was a nice presentation or not, if we should change formats. Let us know on the feedback as well.
Yeah,
Yeah.
absolutely. So thank you, everybody.
Thank you
Yeah,
all.
thank you, Josh, for all the information. It was
Thank you,
awesome.
Josh.
Thank you.
Thanks. Great hanging out with you.
Okay.
See you.